All right. Let me see. Let me take a look at the questions. Okay. So that was 14, 15, and 16. All right. Okay, we'll do it together. Mm, hmm. Let me see my screen. Can you see my screen?
Mm-hmm.
Okay. All right. Okay. So let's take on the first one, which is number 14. Um, it says arrange the following fractions in ascending order. Okay, so I'm going to ask you first of all, do you know what ascending order means?
Yeah, is it from smallest to highest to biggest?
Yes, yes, from the smallest to the biggest.
Yeah.
So that's because it's similar to what you have, the kind of movement you have when you are ascending a staircase. Okay, so you are going from the smallest to to the biggest. So that's the whole idea. Now, the the method we're going to use, I'll say to some extent depends on the fractions that you have. But there's a very common method that's um, that's obtainable or that you can find in most scenarios. So let's look at the actual question, the numbers here. The first one is 3/4. Okay, so I'm going to just quickly write them down. 3/4. Do you have the question in front of you?
Yeah.
Okay. So 3/4, 5/8. What's the next one?
Oh,
What's the next fraction?
um, is it 2/3?
No, 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 no. Do you have 2/3 is the last one?
Oh, 7/12, 2/3.
Okay, then 2/3. Okay, so remember, we've not arranged this yet. This is just us writing the question, about to solve it. Okay, so let's see how we'll go about it.
Wait,
Now,
for this one, do you have to find the lowest common multiple so all the denominators match?
yes, yes, if you have to, that's exactly how you go about it. Did you make any attempts to do it that way?
No, it's because I didn't know. Mm.
Okay, okay. So if you had, a kind of guess, or you had an idea. I mean, there's no harm in trying, right?
Mhm.
It's very possible you could have been correct, at least to some extent. Okay, so in this scenario, what would be the lowest common multiple of the denominator? What
Um,
would be the
24.
24. Okay. All right. So I just want you to take a look at how I'm writing it at the bottom there. I drew a line and then I put 24 right on that underneath it. So we're going to go, the usual way, as if we were adding or subtracting fractions. So I'm going to say 4, the denominator, into 24. That will go how many times? 4 will go into 24 how many times?
Four. What did you say?
4 will go into 24 how many times?
6.
How many times? 6, exactly. So 6 times the numerator, in this case 3, will give us 18.
18.
Okay. Yeah. You put your comma there. Remember, we're not adding, we're not subtracting. So we're just trying to find which one is the smallest and which one is the biggest. 8 into 24 will be how many times? 8 in 24 goes how many times?
3.
3 times. 3 times 5 will give us 15. Okay. The next one is 12. 12 in 24 will give us how many times?
2.
2 times 7 will give us 14. And finally, 3 in 24 would be 8 times. And then 8 times 2 will be 16. So let's quickly look for the smallest, because that's the one that would come first, since it's in ascending order. And if we look very well at these numbers here, you will see that the smallest here is 14, isn't it? So we're going to take the fraction that matches with 14, which is what? 7 over 12, and write it out first, because we're writing it in ascending order. Okay? Followed by 15, which is 5 over 8, right? Followed by 16, which is 2 over 3. And then finally, the last one is what? 3 over 4, isn't it? Okay. Now, would you agree with me that this method is pretty fast, right?
Yeah.
So that's it. That's the solution to the question. This is it in ascending order. Okay, so let me just type it out there. In ascending. Do you have your notebook with you?
Yeah.
Okay. You want to write it down?
Okay.
All right, go ahead. I'll wait.
Okay, I'm done.
Okay, good. All right, so let's move on to the next one. The next one says, what is the place value of 5 in that number there? Did you also look at that question carefully? Place value, because I thought that question would be pretty simple for you. Did you take a look
Oh,
at that question properly?
yeah, is it 500s?
It is. It is. It is. It's 500. There's no. It's That's just it. So that was the answer for that one. So now I'm going to need any calculation of any sort. Number 16. Number 16 says in a school there are 400 and let's see, let me see how many kids there. There are 478 boys and 329 girls. How many pupils are in the school altogether? That's pretty simple too. Are you sure you tried that out and couldn't solve it?
Yeah, I did. It's
You solved
D.
it.
It's D. It's 807.
Okay. So if there was anyone that you had any challenge with, which wasn't even much of a challenge, I guess that would have been number 14. So um, the others were not challenging. And so, okay. So I think I should just go to 17. So we're taking off for what we want to do for today. So let me just go to number 17. All right. So for number 17, let me read number 17 out. Number 17 says the difference. Now, I want you to listen carefully to number 17. It's a question that can be
I don't see
solved
I don't see a number
using.
17. I don't see a number 17.
Yes, yes, yes. Don't worry. I didn't send that as a screenshot to you. That was only the one I sent you for the homework. I have the others here. Okay, don't worry. I'll read it out. I just want you to listen to it. Maybe I'll share the picture with you. Or let me see. Um, did I just send it to you? Okay. Maybe. Okay. So what I'll do is let me see if I can do a screenshot and send it to you. Um, let's see if I can do a screenshot of this and send. Okay, so I'm trying to send it via WhatsApp so you can um okay. All right, so I sent you I just sent you something on WhatsApp. You can take a look at it. That's what I'm making reference to. Okay, so number 17. Let me go back to the question. So number 17, if you can see it, it says now, but more importantly, I just need you to really listen, okay, and analyze it along with me. It says the difference of two numbers is 60. If the smaller number is 90, what is their sum?
It's still
So how would
loading.
you go about
Oh,
this
I see it.
question?
So wait, it's like blurry. Yeah, the difference of two numbers is 60. If the smaller number is 9.
Using algebra, of course.
Wait, the difference of two numbers is 60. Oh, would this be? Would this be 90 plus 150?
Yes, good. So can you tell me your thought process? How did you go about it?
So what I done is if the smallest number is 90 and there's a difference between 60, I added 90 and 60 to get 150. I mean, I added 900 and, yeah, 90 and 60 to get 150, which means that the biggest number is 150. So then this to find out the sum of them, I would add both of them together.
Okay. All right. Okay, that's perfect. So 150 plus 90 will give you what? That would be 240, right?
240.
What did you get when? Okay, that's good. All right. Okay. All right. So let's go to the next number 18. So for 18, you see that they are decimal numbers, right?
Mm-hmm.
So what do you do whenever you have to add decimal numbers together? What do you do?
So what I'll do is I use the column method to add them
Okay.
so I can
Okay.
separate them. And then I'll start by adding the
Okay.
smallest. I'll start by adding the smallest
Yeah.
numbers. So let's see.
Okay. What you call the column method? Is this
So it's when you line up.
similar to
It's when you line up.
arrange?
It's when you line up all the numbers, but in the correct hundredth or the correct 100 or 10 or 10th place. So what I'll do,
Okay. But did you see that these numbers have decimal points in them? Did you notice that?
yes,
So what happens to the decimal point?
what's it called? It's still there. It's gonna be what separates the integer from the decimal numbers.
Yeah.
So what I would
So
do, so if I see that 14.02 doesn't have a number, is it in the first what is it called in the first unit after the decimal?
that's the tenth unit. Tenth with
Yeah.
a th. Tenth.
So since there's no term, no unit in the 10th, it's a 0. What I would do is what's it called? Is I'll add a 0 after the 9 in 13.90 and a 0 after the 7.1, just so it makes it look even. and then I'll start by adding this. I'll start by adding the smallest number. So 0 plus 0 plus 2 is 2. 9 plus 1 plus 0 is 10. So I'll bring over the 1 to the what's it called, ones, you know, and then I'll
Okay.
do 3 plus 7 plus 4, which is 14, plus the 1, which is 15. So I'll bring another 1 over to the 10th, to the tens column, which will be 1 plus 1, which will give me 25 point which will give me 25.02.
Okay, good. Okay, so I guess we agree on something, that the decimal point is priority here, right? We need to make sure
Mm-hmm.
all the decimal points line up, isn't it?
Mm-hmm.
Okay. All right. Nice one. So that's correct. So that was number 18.
18.
So not 7. Yeah. So let me change that 17 to 18. Okay, that's good. All right. So let's go to number 19. Let's see if number 19 is pretty straightforward too. All right. So number 19 says a motorist traveled at 72 kilometers per hour for two and is that a half? For two, okay, okay, that looks like 2.5 hours, right? 2.5 hours.
Mhm.
How many kilometers has he covered? How many kilometers has he covered? So what's this? Do you have an idea what this question is asking for?
No,
Yeah. Do you have an
no,
idea?
uh, no.
Okay. So this question actually is it comes under those questions that or maybe you might not know them yet. But I think if you've done a bit of speed, distance, and time in science, you would it would ring a bell. Okay, so
Mm-hmm.
it it, it comes under those questions that deal with speed, distance, and time.
Mm-hmm.
And there's a formula that makes formula. Let's see. I'm going to write speed equals distance. Have you seen this formula before?
I think so.
Have you? Does it look familiar?
Mm-hmm.
You think so? Sure, you've not seen. Okay. Anyways, if you've seen it before, great. Then it would be a revision for you. But let's just solve it now. Once you understand this formula, all you need to do now is to substitute whatever needs to be substituted. But before I go ahead to substitute, I want to show you something. Now, if you look at that question carefully, look at the unit for speed. Did you notice the unit? 72 what? What comes
Kilometers,
after the 72?
kilometers per hour.
Kilometers. Thank you very much. Now, I want you to remember that anytime you see that slash, that that comes between kilometer and hour that you call per, it actually signifies division. Okay, so the unit for distance is usually kilometers. The unit for time is usually hours. So that unit itself is a reminder of the formula for speed. Did you get that?
Can you
Did
just
you get
repeat?
it? Okay, let me say it again. Now, I said if you look carefully at the units for speed, 72 kilometers per hour. The kilometers is the unit for distance, isn't it?
Mm-hmm.
The hours is the unit for time, isn't it?
Mm-hmm.
So the slash in between the kilometers and the hours is simply signifying division. Okay, did you get that?
Mm-hmm.
So it's kind of a reminder that the formula for speed is distance divided by time. So that's the reason why I said that is, so if in the event of any, if it's possible that you forgot the formula, all you need to do is to look at the unit. The unit will give itself away. Okay, the unit will indirectly tell you the formula if you forgot it. Do you understand now?
Mm-hmm.
Okay, so I just thought I should say that so that yeah, if it happens, if you forgot the formula, all you needed to do was to just look at the unit, and that fact holds true for most things in mathematics and physics, or the physics part of science. There's a biology part of science, there's a chemistry part of science, there's a physics part of science. So the part that talks about motion, Newton's laws of motion, forces, friction, and all that.
Mm-hmm.
Okay, that's the part I'm talking about. That refers to physics. Okay, so let's go ahead and solve this question, shall we?
Okay.
The first thing we have here is 72 kilometers per hour. That's the speed. So you know what we're going to do? Anywhere we see S, all we need to do is to simply put what S is from the question, which is 72. Okay? We don't need to write the kilometers per hour anymore since we're about to solve it, or since we've started solving it. Let me put it that way. Now, the next thing we need to substitute from the question is hours, which is time, isn't it? Now, remember, time is in the denominator. So you have to put the 2.5 exactly where you have time in the denominator. And guess what? The one that we don't know is the one that we're told to find, which is distance, z. So that's the guy on top. So that's the one we're going to find according to what the question says. Because the question says, how many kilometers has he covered? And kilometers is it's a representation of distance. Okay. All right.
Mm-hmm.
So do you understand it up to this point?
Yeah.
Okay, good. Now I need you to just follow what I'm going to say now. All right. I need you to just look at this. Now, if you were going to, I want you to, in your mind's eye, right? In your mind's eye, you are looking for. Okay, hold on. Let me even make it easier. Okay, so if you are looking for D, you know, you know how we solve um things in algebra, right?
Mm-hmm.
Do you remember how we do whenever we have an unknown and we're told to look for that unknown? Do you remember? We usually ask ourselves, how do we make that unknown to stand alone? Is that not what we're aiming for? We want that unknown to stand alone. That's to be on its own on that side of the equation. Now, for D to be on its own, we have to take out or take care of that 2.5. Do you agree with me?
Mm-hmm.
Do you agree?
Yeah.
Hello, Mason, are you there?
Yeah.
Hello?
Hello? Hello?
Okay, so Mason, it looks like there was a lag. Did you hear what I said last? Yes, I
No.
can hear you. I can hear you now. I can hear you.
Wait. Are
I
we
can
are you
hear.
able to like the last
Hello, I
like
can hear you, Mason.
hello?
Can you hear me?
Yeah.
Go ahead.
For like the last like 20 minutes or so, can we look at like area, perimeter and volume? Because I have a test on that.
Okay. Oh, okay, okay, sure, sure. That's fine. That's fine. Okay. So we'll done 30 minutes. So that would, let's just we'll do. I'll switch to that at when we get to 7 your time. Okay. All right. So I said I was going to. We needed to take care of um the 2.5. Okay. So what would we have in this instance? You notice there's a division sign there, right?
Mm-hmm.
So the question would ask ourselves is what's the opposite of division?
Multiplication.
Thank you. So we're going to simply multiply both sides by what? 2.5. Okay?
Mm-hmm.
So I want you to see what's going to happen now. 2.5 on the left hand side, 2.5 is going to multiply 72. And on the right hand side, we're going to also multiply d divided by 2.5, okay,
Mm-hmm.
times 2.5. Okay. Now, when when you multiply something, okay, and that thing find is somewhere on top, and that same thing is beneath, we know that they will cancel themselves out, right?
Mm-hmm.
So this guy is going to take itself out here. So can you see we have d alone on the right hand side?
Mm-hmm.
So let's now look at the left hand side. Let's see what we have there. We have 2.5 times 72. Now we need to make 2.5 an improper fraction, isn't it?
Yeah.
Okay, so we're going to make it improper fraction. So if I make 2.5 an improper fraction, what will it become?
If you make it an improper fraction,
Yeah,
it
what
will
would it become?
if what?
What will it become?
If what?
If you make 2.5 an improper fraction,
Will it become 3?
hmm?
Will it become 3?
Okay, no. Improper fractions. You don't remember how we go about making a mixed number an improper fraction?
I do, but I don't have to turn 2.5 into 1.
Okay, all right. Then maybe I'll just do a kind of reminder here. So I'm going to do this in a box so you know it is not really. So 2.5, right? To change it to an improper fraction, I'm going to simply say 2, the denominator, times the whole number, Okay,
Okay.
2 times 2. Then I'll now add the answer. Okay, I'll add the answer to what? To 1, the numerator. So 2 times 2 is 4, isn't it?
Mm-hmm.
And 4 plus 1 is 5. So the answer would be 5/2. Okay, so that's 2.5 as an improper fraction. So we're going to replace 2.5 there by 5/2. Okay, and then we're going to have 72, okay, over 1. Okay, so let's remember all this is equal to z. Remember, z is the only thing on the right hand side now. So let's go ahead and cancel, right? 2 in itself is 1. 2 in 7 goes how many times?
2 and 3.
Yes, 3 times. Do we have a remainder?
Remainder of 1.
Thank you. We have a remainder 1. So we put that 1 in front of the remaining 2. And that's 12. So 2 in 12 will give you what? 2 in 12
6.
will give you what? 6.
6.
So the answer, so that's going to leave us with 36 then. So the final answer is going to be 5 times 36, which will be what? What's
Wait.
5 times 36?
5 times
Yes,
6.
don't worry.
30. Wait. 5 times 6. 30.
Yeah.
Is it 180?
Yes, that would be 180. So we're going to say, therefore, D is equal to 180. Now, don't forget the unit. The unit is what? Kilometers.
Wait, can you please repeat how you got 5?
Oh, okay. Do you take a look at the improper fraction part? Can you see the improper fraction part? I changed 2.5 to an improper fraction. Okay.
Mm-hmm.
So I multiplied the denominator, which is 2, by the whole number, the big 2. The small 2 times the big 2. So that will give me 4. All right. Then I now added 1. 4 plus 1, the numerator. That's how I got the 5. Did you get it now?
No.
Okay, maybe I should use another one as an example. So let's pretend I have 3.5 as my fraction, and I wanted to change 3.5 to an improper fraction. Again, you take the denominator 2 and multiply it by the whole number. The whole number in this case is what?
3.
3. Yes. 2 times 3 is 6, isn't it? Next,
Mm-hmm.
we'll take 6 and add to 1. Okay, and 6 plus 1 is what?
7.
7.
So 6.
So
6.
the
7.
answer, yes, that would be 7/2. Okay,
Mm-hmm.
did you get it now?
Yeah.
So that's how I got the 5.
And then like the time,
Yes,
like
the
how
what?
you put 72 equals d over 2.5 is like what time is 2.5? What time? How did you get the time for that?
Okay, it came, we remember the question told us the time is 2.5. Do you remember?
No, let me see.
Yeah, take a look at the question. The question said 2.5 hours.
Oh, yes.
So that's how I got the 2.5.
Yeah, I see it.
Okay. Okay. All right. So I want to see if I can get. Do you have some practice questions you want us to solve
I don't have any in particular.
for perimeter and stuff?
No, I don't have any.
Okay. So you said your test is on perimeter and what?
It's surface area. So perimeter,
Surface
surface area, volume.
and volume.
Mhm.
Perimeter, surface area, and volume. Okay. I really have questions on this. I have questions on volume. I have questions on area, but I'm not sure I have questions on surface area. But okay, I could source for some. Okay, no problem. I'll see. I could come up with something. Um. Okay. Hold on a bit. Let me see. I just found some questions on. I'm going to put something on the group now. So those, it's not all of them are on perimeter. Um, they're not on perimeter.
Okay.
But I'm going to just the ones that are on perimeter. Then I'll add one on surface area. Surface area of solid, right? Hello?
Hello?
Yes, I said surface area of solid, right?
Yeah, of a cuboid. Oh, of a cuboid.
Okay, how
Well,
about
both
of a
of them.
cylinder?
No, we
How about
haven't.
for a cylinder?
I don't think. No, we haven't done that one yet.
Okay, so it's just cubes and cuboids, right?
Mm-hmm.
How about perimeter? Perimeter for what shape? All shapes or maybe only squares and rectangles?
I'm not really sure, so uh, I'm not sure.
Hmm?
I'm not really
Okay,
sure.
which ones have you guys done in class?
I can't remember. I think it was. I think it was square, triangles, and I'm not
Did you
sure
guys do
what.
circles? At least you remember if you did circles. Right? You don't remember if you guys did circles.
Nah, we haven't done circle because
Okay,
I think
so but you've done squares.
circle involves pi.
You've done yes, circles involve pi, but you've done squares and rectangles, right?
Squares, rectangles,
Squares.
and
Okay,
rectangles, and triangles.
okay, okay. Squares, rectangles, and triangles. Okay. Did you also do the area of those shapes, or you only did perimeters of those shapes?
I think we done perimeter as well, but I'm not really. I can't really remember perimeter.
Area. How about area? Area. Area, like
Area.
area of a square. rectangle, yes.
Area, I think I can remember.
Okay. Did you guys do that in class?
Yeah.
Okay, so see what's going to happen. I'm going to do my best to just cover everything. There's no harm in knowing beyond what you already know in class. So that we are sure you are, on the safe side. So I'm going to start with, the easiest one, which is perimeters. Okay. So let me see which of these questions I sent to you is has to do with perimeters. Okay, to be quite honest, we don't have any questions there on perimeters, but I'm going to make up one now and we'll solve it. Okay, so let me save this file. Hold on, please. Let me save this file. I'll save it and then um and
Wait,
open a new one.
for the one that you sent to me, number 8, is it just 12 times 4 divided by 2? Is the 7 just there? Because my teacher said that when it's sideways, most of the
Uh-huh.
time it's just there to trick you.
Yes, yes, yes. Yes, you're right. Very correct. The 7 that's on the side is there to trick you, really. Yes, that 7 is a hypotenuse. You don't need it for the area of that for that triangle. You're right. So yes, that's good. You were able to see that. So that means you actually were able to tell. Okay. All right. So let's let me see. So I'm trying to make up a question for perimeter. So can you solve that question?
Yeah, it's 24.
Can you solve that question, Mason?
Yeah, the one that I just. Oh,
Are you sure it's
wait.
24?
Yeah, it's 24. Wait. Yeah, it is.
Okay. Let me take a look at it. Just give me a minute. So okay. So the formula for area of a triangle is half base times height. So half of 12 is 6. 6 times 4 is 24. Okay, okay, that's correct. Okay, yes, we're in good shape then. So that's fine. So you technically have a good grasp of area for a triangle. Okay, so let's talk about, like I said, let's start with perimeter, right? Let's go to perimeter. So just take a look at this shape so you'll be able to identify it. What shape is this?
That's a rectangle.
That's a rectangle, correct. All right. Of course, you know the properties of a rectangle. Um, uh, uh, Opposite sides are equal, right?
The opposite.
And
So the parallel
sorry,
lines of
yes,
the lines of the top and bottom, which are parallel, are still the same length.
yes, correct, yes, and yes. So we could just conclude that the opposite sides are equal and parallel. Okay, that's nice. And the the angles at, okay, but I guess you guys did not talk about the angles, but we know that the angles in a rectangle are all 90 degrees, right? Did your teacher mention that?
I think she did.
Okay. All right, no problem. We don't need angles now though. So let's just go ahead. Did she also tell you anything about diagonal?
Nah, I'm not sure. I don't think so.
Okay, so I'll just mention it. I'm not going to do anything with it. And save as. So diagonal. Look at, can you see this line I'm drawing there?
Mm-hmm.
Right? The
That's
line
it.
I just drew. That line,
Yeah.
yes, Okay, and there's also a second diagonal. Okay, so diagonals, those are two diagonals. They bisect each other into two equal parts. Okay, bisecting just means divide. They bisect each other into two equal parts. Okay, so that's just a property, but you can forget about it. I just thought I should mention it. Okay, so let's go back to perimeter. Perimeter of a rectangle. So what's the formula for perimeter of a rectangle given by P equals, can you remember?
E equals, is it
Yeah. It starts with
um,
2. 2 something.
6? No. 2. I'm not sure.
Length. Okay, don't worry, I'll remind you. 2 times length plus breadth. Okay. Another name for the breadth is the width. Okay. So technically, you remember 7 is what? 7 is the longer side, isn't it? So that's why it's the length. And 5 is the shorter side. That's why it's the breadth or the width. Do you remember?
Mm,
Do you remember that?
Remember what?
That the shorter side of a rectangle is called the width. Like
Oh
this,
yeah.
curve like this,
Yeah.
DT. Okay. Another name for it is breadth. Okay.
Yeah.
Okay. So that's another. Yes, that's exactly what I just said. Okay. All right. So can you now apply the formula? Don't worry, let's apply it together since um you said you don't remember the formula. So let's apply it together. Now you remember anytime in mathematics you see a number coming directly in front of a bracket, there's a multiplication sign there, isn't it?
Mm-hmm.
Okay. So we're going to replace L with 7, right? And what are we going to replace B with?
We're going to
What are
replace
we
B
replacing B
with
with? Yeah,
5.
5. So we now are left with what is in the bracket, which is 7 plus 5. Okay, and remember when you are doing your board math, okay, I don't know which one you know. I don't know if it's board math that you know. Do you know about board math?
Yes.
Okay, so board math says brackets first, right?
Yes.
Okay, so we're going to start with the brackets first. Are you tired? You sound as if you are stretching.
Yeah, I was stretching.
Okay, all right, don't worry. I know it's been a long day. Um, I can also feel a bit of strain here, but yeah, don't worry, we'll make it through. So 7 plus 5 is 12, right?
Mm-hmm.
Okay, so we have 2 times 12, which will give us what? 2
24.
times 4.
Wait, I'm
So we can say FP equals 24. Now, don't forget, the unit for perimeter is simply the unit for either of the length or the width. Okay? I hope you remember that.
Mm-hmm.
So if the length had been 7 meters and the width had been 2 meters, then it obviously can't be 24 centimeters anymore. I mean 5 meters. It will have to be 24 meters. Do you agree with what I just said?
Mm-hmm.
Okay. Now let's go and do one example. And because of time, I'll just try and do one example for each. Okay. Let's do
Mm-hmm.
an example for a square. All right, for a square. Remember, a square. Okay, so now let me try my best. I'm trying my best not to sound confusing. Okay, but in some books, right, I don't know if you've seen books like this. Some books say that a square is a type of a rectangle. Let me take it again. A square is a type of a rectangle. So you can think about it. A square is a rectangle that has all its sides equal. Okay, if you look at it that way, okay, I hope I didn't confuse you back then. If you look at it that way, then we can safely say that the formula for the perimeter of a square. So let me quickly draw a square here. You can even look at this program, this app I'm using, which is you should know this app. Maybe if you use the Windows computer, it's Microsoft Paint. This app doesn't have shape for square. Instead, it's the only shape it has is rectangle. So with that rectangle shape, I can draw a square. And for me to draw a square, all I need to do is just to make sure that it looks equal like this. Okay, that it's not looking like one side is bigger than the other. So I can't really even. This is just a what they call an estimate. I'm not even sure about it. Okay, but then let's pretend it's a square for the purpose of our class, right? So let's give our square size. What size should we give it? Let's say this is 4 cm. Of course, if it's a square and it's anything to go by, then all the sides should be equal, isn't it? 4 cm, 4 cm, 4 cm. Okay, let me do the last one, 4 cm. Okay, so there you go. All the sides are equal. Now, for a square, if a square is a type of a rectangle, okay, follow my argument now. Do you agree with me that the perimeter will be given by, I want you to still watch, because it doesn't look like I performed a magic trick here. The perimeter, do you agree that the perimeter will be given by, now I want you to watch, 2 times, right? Don't worry, I'm not done. No, I'm not done with the formula. Remember, length plus breadth. But we said a square is actually a rectangle that has all its sides equal. So that means it's equal to 2 times length plus length, which is the same thing as 2 times. Now remember, in algebra, we have an imaginary one in front of the L there, isn't it? And we have another imaginary one in front of this other L. So that one plus that one will give us 2L. Do you agree? So we go on to the next line, and 2 times 2 will give us what? 4L. That leaves us with a formula for the perimeter of a square being equal to 4L. Now, let's apply it to our question. So it's just coincidental that the side of our square is also 4. So that's going to be 4 times what? 4, isn't it? And that's going to leave us with what? 16. Okay. 16 what? What's the unit? Can you guess?
Centimeter squared.
No.
Oh, is it just centimeter? It's centimeter cubed.
No.
Or is it
It's
just
just
centimeter?
Yes, just centimeters. Now, let me tell you why it's centimeters. Okay, just you will get it now. All right. Now, I want you to follow me. It's centimeters. Follow me to this point. Okay, look at this. Look at this point here where I'm pointing the arrow at. Okay, 4 times L. Now, the unit of L is cm. Okay, the unit of L is cm. The 4 does not have a unit. Whenever you multiply a number by something that has a unit, it doesn't change the unit in any capacity. Did you get what I just said?
Mm-hmm.
This 4 that is part of the formula doesn't have a unit. So something that doesn't have a unit cannot change something that has a unit. So that's the reason why it will still remain cm. Now, when we go to area, you will see that idea, something is going to change about it. Okay, so do you understand it so far for perimeter of a square? So that we can move on to the next one, which is area.
Yeah.
Okay, good. Do you want to write it
So,
down, or
so
or
perimeter
should I?
so perimeter of a square is just okay, see how it's 4, it's just 4 times 4.
Yes, in this case. So whatever it is that is the side of that square, simply multiplied by 4.
And
Do you
then for
understand?
for a rectangle is P equals 2 bracket L plus
Yes.
L, I mean L plus B.
Yes, yes, yes.
Okay.
That's it. All right. So should I proceed?
Yeah.
Okay. All right. So we're going to talk about area now. Now, for us to talk about area, again, I'm going to start with a rectangle. Then we'll go to a square. Then we'll go to a triangle. Okay. So let's pretend our rectangle this time is what do we say? 9 cm by 7 cm. Okay. All right. So we're now asked to find the area of this rectangle. So area of a rectangle is given by length times what? Breadth. That's very simple, isn't it?
Mm-hmm.
So now I want you to watch. What's the unit for the length? What's the unit for the length?
The unit for the length is 9 cm.
No, the unit, I didn't say the dimension. The dimension is 9. The unit is cm. Did you get that?
Mm-hmm.
Okay. So the unit is cm. Now, what is the unit for the breadth?
cm.
Thank you very much. It's also cm. Did you notice that you have cm times cm? Did you
Mm-hmm.
notice that?
Yes.
So whenever you multiply something by itself, would that not become that thing squared?
Mm. Um. Yeah.
Wouldn't
Yeah.
it?
Yeah.
Thank you. That's it. So that's the whole idea. That is the reason why area is always having squared in its unit. So let's now solve it for this question. That's going to be 9 times 7. And 9 times 7 is what?
9
9
times
times
7 is
7 is what?
63.
63. Thank you. So that's going to be 63 cm what? Squared. All right. So that's it. That's the area for that rectangle. Okay. So let's go ahead and quickly do one for the square. Um, let me draw a square. So let's pretend this is our square, and our square has equal sides. So I'm only going to put the dimension of one side. We already know that all the sides of a square are equal, so there's no need for us to start writing 5 all over. We know that each side is equal to 5. Now, the formula for the perimeter of a square is P. Now, I can prove this formula again using the assumption. Oh my goodness, did I just say P? I'm sorry. It can't be P again because it's not perimeter, it's A. So I said that this formula, we can prove it again with based on the assumption that a square is simply a rectangle that has equal sides. Do you agree with that?
Mm-hmm.
So if this guy has equal sides, then all the sides will be equal to L. So L times L will give me what? L squared, isn't it?
Yes.
That's exactly what's going to happen. So I'm sure you can equally tell too that the unit for the area of a square is definitely going to be squared because cm times cm is cm squared. So in this particular question, the L is 5. So by the time I say 5 times 5, what would that give me? 5 times 5 will give me what?
25.
25, correct. And that's the answer for this particular question. Don't forget the units. In fact, I know some of my teachers back then, if you don't put the units, it's as good as you not solving the question. You either lose a mark for the final step or you don't even get a mark for the question. So it's like you didn't even do the question. So the units are very important, especially when it's a written exam. Okay. Do you have any questions so far?
Nope.
Any questions? Okay, so I
Nope.
hope you are taking note of the formula. The formula for the area of a rectangle is length times breadth or length times width, and the formula for the area of a square is length squared. Length squared. Okay, there's no length, there's no breadth, but it's a square. It doesn't have any of those. It doesn't have a breadth rather. You can just suffice it to say that it has a length. Okay, so let's go on. Let's go on to for the triangle, right? You were able to solve that one that's there, right? I think you got the answer. Uh-huh. So because of time, let's go to another shape. Let's go to surface area. Let's go to surface area so that we can cover some ground. Now, I told you that I don't have any questions on surface area, but let's look at that question I sent you. Let's see if there's any other thing we can solve. Okay, sorry, before we go to surface area, let's do volume. Let's do volume. There's a question of volume I saw in that system. Can you see number 7? Hello, Mason, take a look at number 7. Mason, are you there? Hello? Hello, Mason, are you there? Your mic is muted, Mason. If you say anything now, I'm not sure I can hear you. Yes, I can hear you now. I said you should take a look at number 7. Does it look familiar?
Where?
On the question I sent to you, the one I sent on the group. Does it look familiar?
I don't know. I'm not sure.
Mason, does it look familiar?
I'm not sure.
Okay, so that question is the formula for is is the volume of a cuboid. It's part of the things you guys did in class, right?
Pardon?
Hello?
Hello?
It's cuboid is part of what you guys did in class, right?
Yeah.
Okay, so let's solve that question, right? Let's do it. So can you help me read the question out? Can you read the question?
I should read the question.
Yes, please.
Calculate the volume of a cuboid measuring 12 centimeters by 10 centimeters by 6 centimeters.
Okay. Now, if you notice, that question is quite straightforward. You know,
Mhm.
the formula for a cuboid is given by V equals length times breadth times height. Okay, does this formula look familiar? Have you seen it before? Does it look familiar? Little, a little, right?
Yes, 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 yes.
Okay, good.
For
So,
is that for a triangle
no,
or for a
a
square?
cuboid.
A cuboid.
No, 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 no. Cuboid, cuboid. Okay, it's for a cuboid. Okay, so now take note. Plane shapes, flat shapes don't have volume. It's only things that are like cuboids, cylinders, and the rest that have shape. Do you understand?
Mm-hmm.
Okay. Now, from that question that you read, you didn't notice that they didn't tell us what the length is. They didn't tell us what the width is. They didn't say which one was the height. But all we know is that each of these numbers would represent something. So you know your best bet. Just multiply them like that. 12 times 10 times what? 6, isn't it?
Mm-hmm.
Okay, so let's do that. 12 times 10 is what? 120, right?
Yeah.
120 times 6 will give us what? You know how to do this one, right? We'll first multiply 12 times 6. 12 times 6 is what?
12 times 6 is 72. Times 10
Thank
is
you.
720.
720. Now, the formula for volume. Now, don't forget that each of these is cm. cm, cm, and what? cm. So when you multiply something by itself in 3 places, that's going to be that thing cubed. Am I right?
Mm-hmm.
And that's the answer for that question. Okay? So that's the formula for that's the answer. That's the formula for a cuboid. Okay. Okay. So let's talk about surface area, right? Can we go to
Mm-hmm.
surface area now? Okay. So now
Yeah.
when we talk about surface, let's talk about the surface area for a cube first. Now remember, a cube has how many faces? A cube has how many faces? Take note, I didn't say a cuboid though. I said a cube. A cube has how many faces?
Oh,
Yes, I'm listening.
6 faces.
Thank you. 6 faces. So when you have the dimensions for that cube, right? Let me see if I can quickly draw a cube. I'm trying to sketch a cube, a sharp cube, something that looks like something we can work with. And I think I have the perfect cube here. Oh, I'm good. I'm good. I'm good. I'm good. Okay. So there we go. That's the cube. All right. So let's, a cube, right? And each of the six faces is a square. Do you agree with that?
Mm-hmm.
Okay, that's good. Now, the surface area for a cube. So let me write this down now. Please take note of what we're saying. That this is the reason why I asked you how many faces does a cube have? A cube has six faces, and each of them and each of them and each face is a square. So what that means, I think spell square quite correctly. Okay, so what that means is that the surface area of this cube is going to be the area of one of those squares times 6. Do you agree with that?
Mm-hmm.
Hello, Mason, are you there?
Yeah.
Mason.
Hello.
Okay. I hope you're not drifting. How come you're not listening? You're not responding immediately.
I am. Hold on, I
I
need the
noticed you're
toilet.
not you're not responding.
Sorry.
I
No,
can hear
I'm
you,
saying
Mason.
I'm saying hello, 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 and then you I don't know why you can't hear me.
I think there was a lag somewhere.
I need
Okay, all right,
to
that's fine.
Can I
That's
come
fine.
right back? I need to use the toilet.
Yes, okay. Okay, I think there was a wait. All right. So did you see the formula I wrote down there for surface area of a cube?
Yeah.
So let's now throw in some imagination here. So let's pretend that for this our cube, one side is so we say um 5. Okay, let's say centimeter. Okay, are you still there, Mason?
Yeah.
Okay. All right. So let's say one side is 7. That means all the edges are 7 centimeters. Okay. So let's so that means that the surface area
Okay, give me both their names.
the surface area will be given by Mason. Are you saying
I'm still here. Sophie.
okay? That's going to be 6 times. Now remember that the length
Yeah, that's
for
because you're
each of the
sleeping.
squares, the edge,
That's fine.
okay,
Mm-hmm.
okay, and remember each of the edges is also the size of each of the squares is given by in this particular example 7. So 7 squared, okay, and in this case 7 squared will be what?
7 squared is 49.
7 squared is 49. So that's going to be 6 times 49. So so 6 times 49 will give you what?
Um, 6 times 9, 54. 6 times 4. 6 times 4, 24. 54 plus 70 plus 54. That will give you 78.
6 times 4 is 24, right?
I mean, no, my bad. Sorry. So
Yeah.
6 times 9 is 54. 6 times 4 is 24.
Plus
So
5.
I can't even do this one. I don't have.
Don't worry, it's 29. Okay.
Mm-hmm.
So it's surface area. So just like any other area, it's simply squared. Okay.
Okay.
So did you get that?
Yeah.
Okay. So the only thing I'll just tell you to take note of for cube is that the 7 cm, which is the side for all the faces of that cube, is also called an edge. Did you get that?
Yeah.
Okay, so just take note of it. Edge, that's height. That's height. So, okay. So do you have any questions?
No.
Okay. So are you good with this, or do you want us to also talk about the surface area for a cuboid?
No, it's fine.
It's fine.
Yeah.
Okay. All right. When are you taking the test?
I'm not sure.
Okay, but sometime this week, right?
I think so.
Okay. All right. So let's see. If you've not taken the test by Friday, maybe if you have any other questions, we could take care of those questions before we talk about science on Friday. Would that be okay?
Yeah.
Okay. All right. So I think we can call it a day for now. We've done a little over an hour, or quite considerably over an hour. So it's fine. All right. I see you clapping for it. Clapping for us. Okay.
Hmm.
So that's fine. Yeah. Okay. So I wish you the best in this test. If you end up taking it before our next class. And I would like to hear how you did on the test, maybe the questions, how you found the questions.
Okay.
All right. So have a good rest of the evening and have a good night.
You too.
Bye.
Yeah.